Muhammad teacher will not join us today because he has a problem with his son, little son. There's a problem with his liver. Indeed, maybe we can ask to Mr. Kılıç about his illness. Mr. Kılıç, our colleague's son has a problem with his liver, and he is in emergency service now from Bursa. So he won't join us. Okay, Şebnem has joined us. Şebnem, welcome. Hello.
Good evening.
Akşamınız
Good
hayır
evening.
to Azerbaijan.
Her vaxtınız xeyir, necəsiz?
İyiyiz, elhamdülillah.
İyi olun, hep iyi olun. Good evening, dear everyone.
Hello. Good evening.
I'm sure it's a great night today.
I'm sure about it.
Yes.
We have great guests today, and they are very
Yes.
hardworking, and they will share their experiences with us and with our students. So this night is a very special night, I think, for our students.
Yes, yes. And my students are waiting for it. They are looking forward.
Hello, Sabine. Here's my student. And Antonia. And who else? Ioana, yes. Luca. Yes, everybody.
Benjamin. Where is Benjamin from?
I am from Romania.
Romania. Okay.
It's Adriana, student.
Okay. It's interesting. You have a name as Benjamin in Romania. Wow.
Quite a German name.
There's an. I think it looks like an English name or Benjamin. It's the same. How do you say it? Benjamin or Benjamin?
Like in the English way, Benjamin.
Benjamin.
Benjamin. Like
Mr.
Benjamin Franklin, yes. President of the USA.
Yeah, Benjamin Franklin. And Mr. Kısaoğlu, welcome. Welcome among us. Our another expert today. He will share his experience with us. Welcome. How are you, Mr. Kısaoğlu?
Hello.
Very fine. What about you? I hope
Thank
you can
you.
hear my voice enough.
Your voice is very deep and nice.
Okay, thank you very much.
We are a little bit excited, at least I am, because these expert meetings are can be very useful for our students. So I believe that we are doing a great thing for our students, that we are meeting you and our students, and I'm sure they will learn or have an idea about your works, your creations, and they will try to do or copy you in the future, I hope. So.
I have so to say.
Okay, Mr. Çelen, I think you will start first. I will give you the director. Okay, where?
Yeah, I will start first. Are you sure that every person came? We can start. Can we start?
They are still coming. I think when it's 30 people, we can start. Let's wait for a moment. But I
Okay,
will
as you
give
wish.
you will the host. I will give you the all. Okay, I'm giving it. Yes, you are the host now. You can share your screen, and you can prepare us for the
Okay,
presentation.
Let me check. Are you seeing now?
Yes, I see it. Artificial intelligence, machine learning, and what we are doing in health sciences. Yes, what are you doing in health sciences? Do you wonder about it?
Yeah, I will explain what are we doing. And after maybe 40 minutes, you will learn what we are doing. Okay, I'm starting.
Let's wait a moment. At least I know there will be a lot of students. They are still coming, and it is
Okay.
maybe still early times in Romania, in Turkey. Maybe our students are doing something because there will be a lot of students, I'm sure. And by the way, let's talk about your photo.
can wait
You look very
5
handsome,
more-
Mr.
5 more
Tan.
minutes.
Not like you. You are. I think you are better than me.
No, this photo is perfect.
Thank you.
Şebnem teacher, you were saying something. Sorry, I couldn't hear.
I just offered to wait 5 of more minutes.
Okay, let's wait. We have
Before
time, I
starting.
think.
Mm-hmm.
And also I can do something for additional maybe in that time for waiting moments, let's say. I
Okay.
guess you ask about the health sciences, right?
Yes.
What are we doing in health science actually? Not about my friend's presentation, but about generally I can say. It starts from biology actually, and also always about the human. So we are searching about human healthcare or human science deeply for get more information about our knowledge about the human biology and also general biology sometimes. Because in this health sciences, sometimes we are using animal models, which is very nice to learn about more from these animals, and we are very grateful to sacrifice animal, I can say, from there. They are also teaching us with mimicking our biology, let me say. In the short time, I can say something about that. Maybe my friend also wants to say something about health sciences.
So, you said, Mr. Kısaoğlu, you are using animals while searching about the organs of, they are like, or they have organs like we do. So you are making some experiments on them, but this can be hurtful for them. So, will you use maybe in the future organoids in this field? I really wonder about the organoids. Do you
Yes.
have any knowledge about it?
Yes, I had from like 4 years ago one project about it. It was like artificial cornea project. We were trying to about the organoids. Actually, in health sciences, I can say you obviously no one wants to use animals for sacrifice, but sometimes we have to do it. Otherwise, we are always trying to do mimic projects with, as like you said, organoids. I have been in 2 projects. One of organoid is for liver tissue. We were producing liver tissue, and nowadays at İzmir Biomedicine and Genome Center, this Esra Erdal professor is working with that topic and very deeply. Maybe if you are interested, you can just check Esra Erdal.
We can check it, and maybe I can take some of my students to your institute, and we can see with our own eyes, because my students are, I'm working in Manisa Science and Art Center, and we have gifted and talented students, and most of them are at science high schools, in Fen Lisesi in Turkey, and they are very eager to learn new things, and we are always talking about, indeed, copying people, human copying, what was it? Cloning. Indeed, we are reading some stories and other things about human cloning and organoids. How can we do it? How can we copy human organs in, for example, Petri dish. How can we do it? So maybe you are doing it in your institute, and we want to see it with our own eyes. We can come to visit you if you let us.
I would like to say okay for that.
We are very crazy ideas about it. We want to share it with you. Okay,
I like the energy.
Oh, sorry. I think we can start anymore. Şebnem teacher, what do you say? Do you agree? Şebnem teacher? Because we have 14 minutes, so it ends very easily and fastly.
Yes, I think we can already start.
Okay, we will start with Mr. Çelen, and he is the host now. Let's start.
Okay. Yes. Now are you seeing?
Yes.
Okay. Hello everyone, I'm Kaan Çelen, PhD student at University of Humanities Faculty, a Department of Histology and Embryology. Today we will talk about artificial intelligence, machine learning, and what we are doing in health science. Firstly, everyone heard about artificial intelligence. Maybe everyone heard artificial intelligence maybe one time, maybe 100 times, because artificial intelligence in everywhere now. We are using humanity, but engineer also use or mechatronic and everywhere. What is artificial intelligence? The book definition is artificial intelligence, the stimulation of the human intelligence by software-coded heuristic. What is the meaning of that? What is the meaning human intelligence by software-coded heuristic? To put it more broadly, for example, a code can act like a human. It's also artificial intelligence too. Not necessarily so. Not need to so complicated, so huge, so mixed, so confused. If a code can act like a human, it's an artificial intelligence. For example, you are driving a car, and you saw a traffic light, and the light is red. A code can say this is red light. This is artificial intelligence too. For example, ChatGPT also this is artificial intelligence too. If we say the code can act like a human, it's artificial intelligence. Don't need to so huge, so mixed, so confused. So, if we heard artificial intelligence, also we heard machine learning, deep learning, of course. What is that? What was it? What is the difference between machine learning and deep learning? Artificial intelligence contains all the subsets, machine learning and deep learning. Deep learning is a subset of the machine learning. So, what is the difference between machine learning and deep learning? Machine learning uses algorithm and learn on its own, but may need the human intervention to correct error. For deep learning, uses advanced computing its own neural network to adapt to little to no human intervention. To put it more broadly, for example, when we use machine learning, we should draw the corner, we should extract the feature, and we should give the feature to machine learning to classification. For example, when we talk about the car, we should see the steering, side mirror, gas pedal, engine, and tire. For the deep learning, we don't need to give that, but we need to give a lot of car pictures. And deep learning extract the feature extensions on its own. So, both have advantages and disadvantages. For example, data requirement, deep learning, we need lots of data. Machine learning, we need less than deep learning. Accuracy of course, deep learning is better because of in the deep learning, extract feature on its own, but machine learning, we should give the features and we drop the corners. Training time, of course, deep learning is more longer than machine learning because of we have lots of data. In the deep learning, machine learning is a less data. Also, hardware dependency, it will be same. This is a little bit another example. For example, if we want to teach ECUP and we want to use machine learning, we should give the feature to it. So we should say ECUP has 6 sides and that are square. And then the machine learning learn that, and when a code solve a 6 side, a machine make an inference. Is it cube or no? For deep learning, a little bit different. We do not mention the features. Deep neural network determines features by making interface on its own. So make an inference. This is square or the other one, for example, cylinder. So we was talk about deep learning and machine learning, and we told if we use machine learning, we should give the features. What happens if we write machine learning code and get the features wrong? What's happened? For example, let's use the machine learning code to square object control incorrectly. This is a code screen. We are writing code in here. Also, I'm writing to this code check a square object side. If there is a 4 side, the code say us bu bir kare. Also, if the square side more or less than 4, the code say us no, bu bir kare değil. So, but we forget to write something. We forget to write some code. We forget to check the side length of the square object. If we say this is square, if we say we can say this is square, the square object side length need to gonna be same. But we forget to write that. In the right side, the forget to write code, and when we start to work our code, let's see how it's working.
The square. Yes, which spot that one?
The square.
That's right.
Yes.
And how about the rectangle? That one
Also the square.
goes in there too.
Yeah.
Up next, that's a thin rectangle.
The thin
Guess
rectangle.
where that
The
goes?
thin rectangle.
That's right. It goes to the square hole.
Yeah, we forgot to write that code. We forgot to write that code. So our machine learning, our programs working incorrectly. Our machine learning learn but wrong learn. So code check left side, code check how many side there is, but didn't check left side. So working wrongly. But when we use deep learning determination the properties of the object and make its own definition. So, for example, if we talk about the square, the deep learning checking usual side length, right angles, square base, 6 surface, 6 equal surface. If all these features I mentioned are present in this object, there is our deep learning is yes, this is cube or no. So the deep learning extract the features on its own. So we was talking about deep learning to that, machine learning to that, AI do that. How AI doing that? All thanks from the algorithm, because of algorithm. So the other question, what's algorithm? In book definition, algorithm is set of the rules to obtain the expected output from the given input. What is the meaning of that? What need to understand? For example, our input, our variable be a. This is our input. So our algorithm, let's variable 2 times a. So when we say our a equals equal to our algorithm 2 times 2, so our input gonna be 4. Algorithm doing same. The algorithm doing same. Just maybe the algorithm isn't 2 times 2, but so confused, but doing same. Let's see how the algorithm for the spreading peanut butter on the break works.
I could really go for what you wanted to do here. Do you think you can write down what it does now? Step 1. Get 2 pieces of bread out. Get a butter knife and get a speedy. Take 1 piece of bread, spread it around with the butter knife.
No, Dad, with the peanut butter.
I'm doing what it says. It says take 1 piece of bread, spread it around with the butter knife. Get some jelly, rub it on the other half of the bread.
Dad, go fix this guy.
The thing is too fast. Put the breads together on top of each other. Take a big bite.
Sorry, I had to make it extremely specific.
Oh, good. I'm sorry. Take 2 pieces of white bread out of the bag. Take the lid off the jar of peanut butter. Get a butter knife, stick it inside. With the knife, a bit of peanut butter out of the bit is a lot. There we go.
Better than before, though.
Open the jelly jar. Squeeze it onto the other piece of bread.
No.
None.
That was algorithm, but it's a wrongly. If this is work, if this all step through, we have a successfully peanut butter on the bread, but there is no. So let's see how the algorithm for make a friend. That was also algorithm to make a friends from the Sheldon Cooper. So AI use algorithm, but a little bit different. This is a AI algorithm models for HD yol algorithm. This is when we, for example, give input lots of pictures, the algorithm doing that step by step, and after giving us to output to make an inference. So the pictures you see on the screen now is a pictures OSIT. Now I am talking about what we are doing. What is the artificial intelligence project we are correctly working on at Ege University? This is human egg. The oocyte is a family gametocyte or germ cell involved in the reproduction reproduction. In other words, the immature egg cell. there are different type oocyte, which is the female reproduction cell. The only expert in the field can select appropriate cell for appropriate conditions. In the project we are currently working on, we will be able to select the most suitable family reproductive cell for us, regardless of place and time. Now we are seeing our working on cell. This is a human egg cell, which is different type, and we are try to select best oocyte ever on the work area, and we try to using machine learning in this problem, and our AI model select which is better. For example, the one is B, the one is C, the one is D. This is a oocyte type, and when we was correctly select the best, regardless time and place, we will check the best oocyte ever. Thank you for listening me. This is so hard. Are you hearing me?
Yes, we hear you, but we can't see ourselves.
Thank you.
Okay, Mr. Çelen, can you make me the host again, please?
I forgot to open air condition, so what's open?
Thank you, Kaan.
You're welcome.
Yes, Mr. Kısaoğlu, are you ready?
I will mention later in my presentation. Kaan is our AI and cyber biology expert, and I think it is his first presentation to the people. So he's a PhD student, and I think for your students, it was a great start to understand the basics. Now, the biologist Hüseyin Kısaoğlu will mostly talk about the clinical parts. Then I will talk mostly about the advanced parts, international projects and national ones, our international collaborations and stuff.
Thank you.
Thank you.
And we have 7 minutes indeed. So Mr. Kısaoğlu will start his presentation, but we don't have time. Maybe we can go and come back if you want. So let's finish now and let's come back. Okay?
Okay, for
With the same link, right?
Yeah, with the same link. Everything is the same. We will come back, all students and dear colleagues. Maybe there will be 10 minutes break. I'm not sure about it. But we will try to come back as soon as possible. Okay? I'm finishing the seminar now. Okay.
Okay. See you again.
Kubilay Hocam. Kubilay Hocam.
Selçuk Hocam.
Ne zaman sizin şey başlayacak? Sizin sunum. Yani Hüseyin Hocam herhalde kaç dakika yapar? Yani sizin şey ne zaman başlar?
Hüseyin'inki bittiği gibi diğer toplantının organizatörüyüm, katılımcısı değilim. Sadece
İşte,
görüntüyle her şey yolunda mı diye bakıyorum. Bir sorun yok. Hüseyin
Hani şeyden dolayı bir 40 dakikamız daha var ya, yani onu bitirince bir daha gelmeyelim yani öğrenciye tekrar. Bu 40 dakikada her şeyi bitirelim inşallah.
Benimki biraz daha kapsamlı. Yani şu anki bir şey söyleyeyim. Meslektaşlarım biraz altyapısını hazırlıyor. Kapsamlı dünya. Çünkü attığınız mailde şey gibi hatırlamıştım. İş fırsatları, alandaki eksikler
Ha,
neler?
evet,
Onlara
evet,
da
evet,
teker
evet.
teker değinmeye çalıştım. Arkadaşlar
Tamam.
altyapısını yapsınlar. Yani bir gir çık daha ihtiyaç olabilir, söz veremem eğer vaktiniz varsa.
Olabilir. Hadi ben hatırlatayım. Olursa seviniriz, olmazsa geliriz tabii ki. Yani sonuçta bunun için buradayız. Sizin tecrübelerinizden faydalanmak için. Evet, öğrencilerimiz gelmeye devam ediyor. Is Mr. Ksaoğlu among us? He's not among us yet, I think. We have a Vlad among us. Who is Vlad? Vlad Tepes from Romania. Vlad.
Is it abbreviated form of Vladimir or it's just like that, Vlad? Yes.
Where is he?
It is look like a Russian name because Russian people use Vladimir like Vlad in short form.
Indeed, Ukrainians are using the same name, Vladimir. For example, the president of Ukraine is Vladimir, and Russian's president is Vladimir.
Yes.
They are the same nation, but they can't get well with each other.
And the people with this name in childhood they are called Volodya.
Volodya.
Yes, yes.
Shebnem teacher, why you still in Azerbaijan using Eva? I think it's a Russian thing. For example, your surname is Shebnem Nagieva, Eva.
Yes, yes.
Why
So we
is
can
he-
change.
Why you
It
use
is remains from Soviet times, and
I
not
know.
all, yes, not all the people. How can I say? Make busy with it. We change it in our children, in our kids, step by step. It's going slowly. The process is going slowly because there is no official order, no official rule to change it.
Because it has been, I think, 30 years or 33 years.
Yes,
It is
yes,
over, and
have
we
been a
want
long
to
time.
see, as a Turk, as your brother and sisters, we want to see you as oğlu or kızı, Şebnem Nacioğlu, for example, or kızı.
Yes.
It's interesting for us, really. We don't understand, as Turks from Turkey, we don't understand it. Why
And
you still
you
use
know,
it.
we still used to this one. That's why to change it, it seems us somehow strange. We still use this, but we're gonna change it. 50% of the population of Azerbaijan has already changed it. For example, Mehmedova have changed Mehmedli. Aliyeva had to change Alizadeh. We are
Yes,
changing.
very nice. It sounds more natural for Azerbaijan, I think.
More
Okay,
Turk.
our presenter is among us, Hüseyin Ksaoğlu. Welcome back, and it's your turn. We are listening to you. The word is yours, and I will make you the host, Mr. Ksaoğlu.
All right.
Yes, you have the full power now.
Okay. I'm trying to add my presentation here. How can I add my presentation from here? It's not directly clicking and coming to area.
You can't see anything on the screen yet.
Trying to upload my presentation like still. I can't upload my presentation actually. Is that from screen share site or what?
Bottom side, there is a screen share
Yes.
button. Screen share button. Bottom
Right.
side. Ah, yeah.
I'm opening them. Sorry for late. Okay, now everyone can see?
Yeah.
Yes.
Alright, hello everyone again. Today my presentation topic is about one of the artificial intelligence job area. The question is, can an artificial intelligence based model predict human embryo viability using images captured with an optical light microscopy? So by the way, I'm PhD student at Ege University and 4-year experienced embryologist, I can say to myself. My presentation content is about information about this area, study design about pilot study, result discussion, and later on limitations. And I made a bonus for you is about the future side of artificial intelligence in vitro fertilization area. So development of an artificial intelligence-based assessment model using static images captured by optical light microscopy during IVF, that's mean in vitro fertilization, for the prediction of embryo viability. So main question about in vitro fertilization is infertility. So I write on the left side, as you can see, the main problem is can't get a child from this couple, and you can read that all. I will explain about this little picture. There's some reasons individuals can't get a baby from their relationship. Sometimes it's from a male factor, that's 40% as you can see, and sometimes it's caused from female factors, it's as you can see 40% again, and sometimes we can explain the factors. It's not only from individual steps, means sometimes it's up to genetic side, and as you can see on the right side, sometimes it's about ovulatory dysfunction or 12 factor or genetic background. And I will tell you about how IVF laboratory works from this picture. First, they come to individuals, couple come to center or IVF center, and they talk about their treatment and what is the problem actually. Later on, doctor decide about treatment, and they pay for the reception site, and doctor starts with stimulation of human ovaries, let's say. After the stimulation, with doctor and embryologist collects and pick up the oocytes, because we will need oocytes with injection with sperm later on. And on this side, embryologist will decide will we do classic in vitro fertilization treatment, or we will do intracytoplasmic sperm injection to oocytes. After all, if we get embryos, 1 or 2 or more, let's say, doctor can transfer the embryos, or doctor say, let's collect our more embryos at our embryo bank. So if we get success from this treatment, we will go to right side, and then we will go for the baby process. And if we fail, they will be new attempt. We can try new treatment methods, or they can leave our clinic. It's up to couples, let's say. So that's me at laboratory. So 4-year experience, as I said, I'm working at embryology laboratory, and this is on the right side, as you can see with my cursor. We are mostly using that machine. We call it ICSI, intracytoplasmic sperm injection manipulator. So it has 2 controllers on left and right side, and we are all the time doing our own treatments on this oocyte and sperm with this machine. On the left side, I'm showing you right now, there is a camera. This is very important for us because we can see what we do from this screen. So let's go to other slide. From there you can see better, I guess. This is manipulator. You can see the controller sites, and there's camera. Is very important for us. because we will see better quality pictures of this embryo development process. So on the left side there is a screen. It shows us what are we doing in the moment. And on the right side, this machine is not finding in this IVF laboratory so often because it's very costly and it's very expensive machine. Let me say about this machine price nowadays, 150,000 euros. This is embryoscope, which means we can see embryo development after we did ICSI on this manipulator and we just move to that machine. We can see our embryo development for 24 hours. So this is very useful for us because we will see if there is a problem at embryologic site, this development moment, so we can handle with it sometimes. For example, if there is a vacuole, that's mean empty free zones in this embryo, sometimes we are using laser, as you can see on the left side, for just blow the bubble, and embryo continues to development after that. So there will be a video.
We can't hear the sound.
Sorry, you can't use?
We can't
Can you
hear
see?
the sound. No, we see, but we can't hear the sound.
Okay, I can explain about this because it's open actually. But maybe
Try
about
again.
my microphone. Okay, maybe about my microphone. Just a minute.
My asthma. They said they'd fix it, but
Yeah, we can hear now.
All right, it's about microphone. I guess. Oh, sorry.
my asthma. They said they'd fix it, but it didn't make any difference at all.
Well, sometimes doctors make mistakes. But once it's hard to fix it. Using your inhaler?
All the time. Go through one a week.
Sure you're using it right?
Do I look like an idiot?
No. Why don't you show me how your inhaler works?
Mr. Xolo, now we can't hear you. No, we can't hear. Ah, yeah, we can hear you now.
No, it was me. Sesin gelmiyor Hüseyin. Şimdi geliyor Hüseyin.
Yeah.
Sorry about it. I want to explain about this video. What matters most is how you see yourself. So there must be a control mechanism here so that we can see ourselves correctly. Okay, this image is from time-lapse microscopy. I will explain you about what embryos look like during development site. Let's look at the right side on the top. This is, for example, this fourth day embryo, and it's developing. On the top side, embryos are mostly good quality embryos. So in this AI project, we want to do separate good quality and bad quality embryos, because good quality embryos gives more birth rate to us. So I will tell you about the numbers A, B, and C. That's mean it's a grade, embryo grade step. 2 is like about the size, 3 is about size, 4 is like bigger, as you can see, and there is 5, it's like the last point of the embryo during IVF, just laboratory watching about that. So this is on the top side, as you can see, 4AA. This is best quality embryo actually. And the 5CA is about this embryo photo. That's mean now embryo is it has many cells and it hatch to outside of this zone. So this is a very good embryo, let me say. We all born from embryos, but we don't know which quality are we, let me say. And on the bottom side, machine will separate this, let me say, bad quality embryos. All is live, all is living on the embryo development process, but they are not so good quality, and because they have less cells than these are, as you can see. So this pilot studies article is development of an artificial intelligence-based assessment model for prediction of embryo viability using static images captured by optical light microscopy during IVF from 2020. There's embryo selection process. It's very important for us. I will start with this one. Embryo selection following in vitro fertilization is a critical factor in determining the success of the pregnancy, because better quality embryos gives us mostly better birth rates. Then look at the second. Embryologist choices can be variable, and time-lapse imaging techniques are costly. As I said, it's very expensive machine, limiting and widespread use. So it does not have a reliable predictive ability for clinical pregnancy endpoint, and this is very important. This selection standardization is difficult even in a single laboratory, making it impossible through the industry. I will just show you this picture is about my explanation. All these colors are red, but which is like our common red, let's say, which we say to red. So it's blood actually. Mostly we say blood to real red, but the others just variations of the red. So in embryo laboratory, there is many embryologists working together, but all can decide different for the good quality embryo. I just put that picture to explain this actually. There must be standardization for get success. And also from this chapter table, as you can see with vegetables, every embryologist, also a human, let me say, sometimes doing job with emotions. So we are emotional creatures, and this is a risk if you use your emotion against the good quality embryo selection. So all the time we must say this is good quality embryo or this is good chocolate. Purpose is to develop non-invasive artificial intelligence-based predictive assessment using two-dimensional images with optical imaging method. So my friend Kaan has explained very good about artificial intelligence generally, I guess, but I will just show the simple way. So what we are learning to machine, these are types of cats. Okay, now machine learned what cats look like, and also we are teaching what is not cats. So we are just example given a dog there. So machine now can decide about this is cats and this is not cats. And then it's deciding about the classification. For example, left side is for cats and right side for not cats. And also the same picture with my friend, machine learning and deep learning differences. I will not explain about it more. Just our challenge, each clinic area is unique and requires a tailored approach to solve the problem at hand. So let's look at the image casting. Our artificial intelligence software, let me say, is cropping from this picture as like that. Then it can decide is this a good quality embryo or not. So in this layer diagram of from input prediction, in this project they want to select about this good quality embryos and bad quality embryos, let me say. This is the limit, like it's like borderlands of two embryo selection about good quality. 3BB grade is about limiting these embryos. If it's equality 3VB or better than 3VB quality, machine say this is alive, and we will teach to machine with pictures, and if it's not good as 3VB or lower than that, we are just saying non-alive. So there is two options for machine. On the last separation, it's deciding and giving us a prediction. So let's look also again, sorry. Model selection and flow charts. It will start with data collection. Data collection is very important for us because we have to get many pictures from these embryos for to decide, let me say, like certain way. This is 100% good quality embryo, and image pre-processing is starting. As I showed you before, this cropping the embryo photos, it's just doing for color normalization and embryo centered and cropped. It makes optimize for to select it, split it into data sets, later image augmentation, then model architecture selection for us, deep learning or machine learning, I mean. And we are using deep learning in this pilot project. After model selection for ensemble, I will show you some numbers. From this experiment, there is total images 8,000 and more than that. That's been we need very too much photo of embryos and developing embryos, and some of them is select for pilot study, and some of them select for pivotal study. Pilot study is required for improved training technique. So all of these embryo pictures get from 11 independent clinics around the world, as you can see, from Australia, New Zealand, or United States, or the different centers in United States. They are always feeding the machine learning, let me say. And we will see about the simple results of pilot study. Now you can see AI model accuracy is as like 71%, and embryologist accuracy is 47%. So maybe you can understand now why we are, I said, emotional creatures, because embryologists sometimes can't decide. So I can say this is non-alive because it's living process. We can decide as sharp as that AI machine, let me say, from these pictures. So let's look at the success rate against human to AI, our system. 2.7 times it's select better than human. So I want to offer you about one project. It's like a time break right now for you. Maybe you can print screen to this area. This is very nice. World know, I guess, this company IBM. They made one project. The project name is Project Debater. There is one professor and one AI machine, both of trying to debate about one topic. Maybe if you have time, you can watch this. And let's look at the pivotal study group. It also shows here AI model for fold improvement, 2.2 times better than human, and at all on the right side, increase rate compared to embryologists, as you can see, 42%. So it works better than us, actually. Let me say, it's maybe horrible, but we can't decide sometimes sharply. So this is error matrix. Embryologists will make a mistake, and also machine will make a mistake. But machine mistake is lower than us, let me say. And it's again a second horrible side for me. We can decide as AI, better as AI, let me say. And embryologist distribution of scores and AI model distribution of scores. What does it mean? So embryologists mostly decide many of these pictures to grade 3. But let's look at the AI. It's beside 1, 2, 3, 4, or 5. So it's been different grades. Probably it's machine choose it sharply about these pictures. It is good or less. And look at the discussion. AI is more confirmatory than embryologists because embryologists have a greater tendency to classify living things. Because there is an obligation and choice to allow a non-viable embryo to be transferred to later allow a viable embryo to be discarded. It is not that easy for us, let me say, also in clinics. Blastocyst formation is limited in prediction pregnancy because it is not a reliable indicator of clinical pregnancy likelihood. It's not just one thing we can say we are not successful about this. There's many reasons, I mean. The accuracy of embryologist grading methods in predicting the clinical fetal pregnancy is actually low. So look at limitations. The AI model developed here is limited to the analysis of day 5 embryos. So days are limited. Therefore, a model should be developed to evaluate embryos from different time points. The defined endpoint is clinical pregnancy as measured by fetal heart rate. This is like a start point of, let's say, now the creature is developing inside and does not indicate the likelihood of live birth. The research is retrospectively. So this picture is already taken in sometimes some time period, I mean. But nowadays we are trying to do it when we did intracytoplasmic sperm injection after directly upload to software for decide about this live birth rates. Therefore, real-time data should be used to enable to use of AI going forward. I will just say about my own project quickly. I did that project in Bahçeci Umut Istanbul Clinic. It's Future Fertility. It's with Future Fertility company, so we call it Future Fertility AI project. And I also used retrospectively photos from time-lapse microscopy and patients from 2016. And also I had for to get more numbers of these pictures, like my last point number is 172, but I completed all project with, I guess, 3,500 pictures from the this host patients. So we only choose embryoscope cases on there, and these are like limitations of us, like decision points for us. We just decide about if these limitations in this project. So Bahçeci has own software for decide to embryo quality or also developing oocyte quality. I will just give us a little example about it. This is the option to select diameter of oocyte. This is about cytoplasm is granular. Yeah, I mean it's good or bad. Let me say by the simple way. And also it has polar body. It's happening after development. Is that fragmented? Again, is by the simple way good or bad, or etc. etc. As you can see in there, we can select them. So I just transferred that information to Excel data for give to AI model software for outcomes. Outcomes are very important for us. So we did that project with Future Fertility. It's connected with Canada University at Toronto, a special company actually, a private sector again. And for maybe help you to about future, after this having big data is also is very important for us. Now I explained to you about outcome prediction. That was this pilot and pivotal study. But what they can do in NASA, for example, if we move to another planet, we have to do that treatments also in zero gravity environment. So robotic surgeries still continues about artificial intelligence and human models. So second side is about reproduction medicine. Is clinical practices is very important for us. Sperm cell classification. And what I did, this is about embryo selection. Our project is about embryo selection, and we are now doing in the Ege University oocyte selection. This is, as you can see, all from closed feature, let me say. And we should use AI because cost-effective assessment and clinic decision system. This AI model will help to embryologists decide about which is better. And last of my slides, there will be again one video. I will open the microphone again. This is about sperm cell selection. Now this is using in real time in laboratory.
Bugün sizlere tüp bebek tedavilerinde kullanılan bir teknolojiden bahsedeceğim. Yapay zeka ile akıllı sperm seçimi. Çok kısa süre önce dünyanın sayılı tüp bebek merkezlerinde kullanıma giren yapay zeka ile akıllı sperm seçimi Türkiye'de ilk ve sadece Bahçeci laboratuvarlarında kullanıma sunuldu. Peki bu sistem nedir? Nasıl çalışır? Embriyoloji laboratuvarında
we are just uploading many good quality sperm pictures to AI model. Then during lifetime, there is many sperm just washing, just as you can see, going around, and machine will say with the green circle, this is better if you choose this sperm.
Sperm seçimi için özel mikroskoplar kullanıyoruz. Yapay zeka bu mikroskoplara takılmış kameralar ve özel yazılımlar ile insan gözünün bile algılamakta yetersiz kaldığı sperm hareketlerini analiz ederek veri tabanındaki milyonlarca spermle karşılaştırıyor. Milisaniye düzeyindeki bu değerlendirmeyle yapay zeka hareketleri en iyi olan spermleri seçerek embriyolar üretiyor. Bakın görmüş olduğunuz yeşil.
As you can see here from the screens, is deciding about the good quality sperm and just circling it with green side.
İşaretli sperm, yapay zekanın gerçekleştirdiği analizler sonrası seçtiği sperm. Bu şekilde işaretleyerek embriyologlara en sağlıklı spermi bildiriyor. En sağlıklı sperm hücresinin seçilmesi çok sayıda kaliteli embriyonun oluşmasına katkı sağlıyor. Böylece tedavideki başarı şansı da katlanarak artıyor. Bizler de Bahçeci laboratuvarları olarak bu yeni teknolojiyi hastalarımızın hizmetine sunmaktan mutluluk duyuyoruz. Bugün sizlere
and thank you for watching me.
Thank you, Mr. Kısaoğlu. As far as I understand, with better algorithms, I think in the future we won't need doctors, or we will have robot doctors, not human doctors. Is that right?
It's not right actually. Sometimes we need also lifetimes, like as human, because AI can't decide very sharply about something.
But you said humans are emotional, and while deciding about a person in life or death situations, I think they can be emotional and give wrong decisions. Maybe we can trust more to AI in the future about medicine.
Maybe for
I understood from your presentation this.
Presentation, I can do that for you.
Okay,
because
thank you.
this is long term. I have to explain more. I mean.
Okay, we will. I hope we can talk face to face in the soon time. Okay, Mr. Kılıç, we have very limited time, and I hope because of this, we have 5 minutes. I think we should come back. Okay, let's go. All students, sorry, this is our third session. We'll go and come back for the solist. How can I say it in English? I don't know. So our presenter, Mr. Kılıç, will be here in a minute. Okay, we are going and coming back. So, Diana, did we go and come back? It was very fast. Kubilay Hocam gidip geldik mi? Ne kadar hızlıydı bu? Çok hızlıydı. Normalde bir 10 dakika, geçen haftaki toplantımızda 10 dakika ara vermiş mesela 40 dakika. Sonra bir daha 10 dakika dedi mola, bağlatmadı bizi. Sonra bir daha 40 dakika. İlginç. Şimdi hemen bağlanabiliyoruz. Enteresan.
Öğretmenim ben herkes yanında yetkili rica edeyim sizden sunum yapmayı.
Hemen hocam. Hocam senin İngilizcen benden iyidir. As-solist'in İngilizcesi ne olabilir ya?
As-solist, valedictorian. Bu yani konuşma yapacak kişi. Bilmem.
Öyle mi dinliyorum?
Valedictorian kulum.
İlginç.
Keynote speaker. Keynote speaker.
Keynote speaker, okay. Ben de yeni bir şey öğreneyim. Her zaman öğrenecek bir şey çıkıyor. Evet, ana konuşmacı doğruymuş. Keynote speaker. Böyle hocam şeyi merak ediyorum ben. Bu yapay zeka programlarını siz sonuçta bir yerden alıyorsunuz değil mi? Yani bunu yazan ya da yapan değil de onu kullanmayı öğreniyorsunuz. Buraya uyarlıyorsunuz. Sizin yaptığınız bu. İkisi de.
İkisi de. Mesela Kaan sıfırdan yazıyor. Şu an bizle beraber hala. Evet, Kaan sıfırdan yazıyor. Bizim projeler için. Bazen de burada göstereceğim. Çeşitli projelerde de başka projelerde hazır kod kaynakları yazdığınız oluyor. Ama ne kadar in-house datayla ne kadar kendi yaptığınız olursa o kadar kıymetli oluyor. O yüzden yavaş oluyor ama kıymetli oluyor.
Yani çift ana dal yapmış gibi oluyorsunuz. Bir yandan yazılımcılık aslında
Evet.
değil mi? Bir yandan da bu biyoloji
İkisi birden.
ya da histoloji ikisi birden gitmiş oluyor.
Evet.
Zor iş, kıymetli bir iş. Aynen. How many students? 13.
Bir gürlek oldu. When everyone is done, when we are in number, I can start whenever you want. It's up to you.
Okay. When we are 20,
I think we are also waiting for the teachers. You're right. Hello again. Thank you for the understanding. I have one more meeting here. We managed it. We figured it out. Now I'm completely free, completely focused on here.
What was it about, the other meeting?
It was a career meeting about medical biochemistry. It was a series, first week. I also spoke on the name of histology and embryology. Then we speak about microbiology. Then assisted reproductive techniques, like Hussein talked about. Now medical biochemistry. Next week it will be about stem cells, and the last week about students' experiences in the field. It is a series of the career speeches. So I'm the organizer. I also see Hajar here. Hajar is our student from Ankara University. She was also the moderator. We organized it. I also invited her to see one more conference.
Hoca'nın hatırlıyor musun? Bir tane webinar vardı. Toplantının ortasında 5 dakika sonra kapanacak yazdı.
Biz de teknik sorulardan bahsediyorduk öğretmenim. Bu tip şeyler böyle o kadar
Vallahi oluyor.
hayatımızda çok olduğu için karşılaşma sıklığı da arttı.
Evet.
Dünkü
Ya-
etkinlikte sadece ben katıldığım zaman arkadaşımın sesi gidiyordu. Yani konuya hiç alakam yok. Ben girdiğim an sesi kapanıyor, ben çıkıyorum, sesi açılıyor. Çıktım en son. Telefonda misafir gibi girdim. Dedim ben ayrılayım o zaman.
Vallahi şeyler oluyor. Bizim geçen yıllarda bir ortağımız vardı. Şeyde çalışan, Ar-Ge'de çalışan. Onun full Zoom'u vardı. Biz 1 saat, 2 saat, 3 saat gidiyordu yani. Şu ücretli Ar-Ge'de olduğu için. Böyle bir şey bize de lazım aslında.
Teams
Ki
kullanıyoruz üniversitede. Orada bile
İki
sorun
kere
oluyor.
verdi, ona şaşırdım ben. Normalde geçen haftalarda hani 40 verdi, 10 dakika sonra 40. Bunda 2 tane gittik ya, dedim ama iyi gidiyoruz. Şansımız açık bugün. Welcome back everybody.
I see that you speak very fast. In your-
Indeed, it's a little bit late. I hope all our students will continue to join us. Okay, where are our students? I will take smile, say cheers. I will share it on our social media in our school. Okay. Thank you very much.
Hüseyin is on his way.
It is so Hüseyin.
I'm on my way.
Really, really mobile.
I hope our students could understand. We changed the link. We said let's not wait for 10 minutes, but I think the students will understand that the link has changed, so they will still wait, I think, somewhere.
I couldn't see any Azerbaijani colleges. Probably
Yeah,
they
I
are
think
studying via link.
maybe. I shared it in our teachers group, the link. This is the new one, I think.
Hoş
Sheldon
geldiniz
is
Şebnem.
here. I was asking about the stem cells. Are you producing stem cells in your laboratory?
Yes, we are producing primary cultures, stem cells, mostly in during this period, mostly from teat pulp and adipocyte from liposuction material. Teat pulp is a main source of mesenchymal stem cells, which means mesenchymal stem cells has a huge potential. They can transform many kind of cells. For the adipocyte-derived stem cells, they are mostly used for regeneration, but of course not limb regeneration. It's mostly like anti-scar effect, and it is against if you have huge wound coming from the some heat injuries, the adipocyte-derived stem cells using for making your skin look smoother post-operatively. So in that period, we are mostly working on pulp cells and adipocyte cells from liposuction.
So there's a great potential in this field, I think, in stem cells, because you can make people young again, maybe for
Yeah,
making
in
skin
a way of
better.
perspective, you are right. They may look younger. We can use it for organ regeneration, but the problem is mostly about teratomas. When we are using stem cells, we are not only using their positive sides, we are also using their negative sides. So when an individual had cancer, it is because of the genes, it's because of the genome. A cancer cell, once a somatic cell, it was once a stem cell. It has its potential, it says its cancerous potential from it is the youngest period, which means stem cells. So when we are using stem cell therapies, we are also carrying their bad habits. When we are doing some kind of genetic modification, we are changing something we still can't understand. So yes, there is a potential, but it still has a dark side.
I understand.
Is there a difference between the stem cells that we use from babies?
Yeah, like cord
and
blood.
babies? Yeah.
Yeah, cord blood. We are using their cord blood from babies. We also, for example, in our university, we have cord blood banking. When a newly born just coming on to the life, we are taking the cord, the umbilical cord. It's connecting baby to the mother, as you know. We are collecting the blood from here and just choosing the mesenchymal stem cells, which has the best potential. So we are using them for autoimmune diseases and some cancers like leukemia. Probably you all know from the popular culture or some kind of, it is very famous that when one of the siblings have leukemia, sometimes doctors suggesting parents to make one more child. So it is actually not about the child, it is a source of stem cell, the closest to the sibling. But when we have the individual's own stem cells, we don't need it anymore. So yeah, baby stem cells is also important. Not baby stem cells, but cord blood stem cells is also important.
I wonder about this. Can we create, for example, we have huge servers, internet servers, you know, and our brains are like a server. We save all knowledge from birth to death in our brains. Indeed, can we use it, a kind of server for computers, a tissue, I mean, brain tissue or neurons? Can we do it?
We are mimicking it. We are not doing it. It is, how to say, it's kind of fantasy because we don't need it. But what we are doing in the networks is kind of mimicking the brain. It is like, yeah, we have huge birds, but we are still producing some just paragliding, right? We are still producing the inorganic versions. Yeah, for brain, actually for the networks, for the also neural networks, for machine learning networks, like Kaan mentioned before, we are not using organic brain, but we are mimicking how it's working on. So we are just connecting like dendrites to axons. It is the same organization. We are just mimicking not only the animals, we are also mimicking ourselves. So for the organic brain, we don't need it because it is still uncontrollable. Even for morphology, we are still finding something new. Like one of our professors, who is one of the best in his kind, Professor Gülgün, is working with Professor Paxinos about Brain Atlas. Up to this year, let's start it from Vesalius. Let's start it from 16th century, maybe a little bit more. Maybe let's start it from Da Vinci, from 15th century. We are still discovering new morphological structures in the brain. So it is still too early. Sometimes we are just think that we solved all the problems about humankind. Yes, we learned everything. No, there is still a lot to go.
Wow. So we are the best machine in the world. As you said, I think you look at humans as a machines, a kind of machine indeed.
Until we have done the better version, and now we will be in a repetitive questions. So who is the best machine? The machine or the individual who created the machine?
Machine creating machines indeed. Look.
It is the question we must ask philosophically. Who is the best one?
Okay, let's start. I think students think that it's too late for them, or they have some other things to do. We can start, I think.
Okay, let's start. Give me a moment. Let's check. You can see me, right? The orange dot. Okay. Now, for the last part, I will talk about histology and AI, artificial intelligence. First, I want to mention what is histology. Histology is kind of a microanatomy. Anatomy is like a poster guy of our field because everyone knows about skeletons, muscles, and their fancy names. Histology, we are going deeper to understand these structures. So when you think about muscle, you will see the whole muscle as a gross anatomy. When you are looking at up to 5 micrometer, now you are in the histology. For histology, we are using, we have some branches, histology itself, so microscopical anatomy, it the first, we can say. We have cytology, which is really important, so it is now the cell science. We have also paleohistology, which is the ancient histology, and we have histopathology. It is not pathology. Pathology and histopathology, two kind of things. Pathology is a branch of the clinical science. Histopathology is mostly, it is basic version. In histopathology, we are understanding how some agents, how some drugs, how some, some additions work on human cells, human systems. For pathology, it is kind of branch of the medicine. Pathologists working mostly on the abnormalities on the organism. Here, we are doing mostly research and some kind of improvements. Histological process I want to talk about, I think it is one of the most important questions in histology. What are we doing it? How a human part becoming a microscopical slide? First, in histology, we are using some tissue sectioning. Tissue sectioning, we can say there may be an animal, maybe a human. We are choosing our tissue and we are making it sectioning, and we are making fixation. Fixation, we can say fixing it. We are just stopping the time for that organism, for that part of the tissue. It means it has its own structures, its own morphology, its own differences. For example, if you are working on the liver and you want to working on the effect of alcohol consumption, you have cadavers, and two kind of cadavers, more or less the same story. One has a so-called healthy liver, and one has so-called alcoholic affected liver. You are taking these parts. We can call it tissue. We call it tissue sectioning. Then we are fixing that parts to stop the time for that organisms, to understand the differences, to understand the morphological comparison. Then we are doing our washing to get rid of blood. Blood is the part. If you are not working on blood, you don't want blood because it doesn't make any sense in our measurements. And we have some kind of dehydration. Dehydration means we are just putting water out of the tissue and we are clearing it. Clearing here is the most important part because I also have my own project in my mind. My college can't just make me think about it. We are lack of artificial intelligence in that part, clearing. Here you see more sections, embedding, sectioning with microtome, staining it, mounting it, seeing it, but there is no artificial intelligence, no technology in that parts. In histology, the problem is artificial intelligence focused on the results, not in the process. So, for the results, we have humans, we have a lot of doctors, a lot of doctor of philosophy, medical doctors. We are still working on it, and actually, we don't need AI as much as this part. This part is more like a labor dependent. So, but when I search for the literature, when I search for the scientific papers, I couldn't see anything to want to improve that part of histology via AI. So it is one of the questions. If there is still student hear this parts is like still version about AI technology. Every part of this, there are nine parts. Every one of this has a potential can be worked on AI. Fixation, we talk about. You are just stopping time. You are making dehydration. We are using alcohol series on it from 70% to absolute 100 series because we don't want any water in our tissue. Why? Because we are clearing it. Clearing section, as I said, it is one of the most important point because in clearing, I think, yeah, now I have my laser. Here you can see it is actually an organ. In clearing section, you are changing organic materials. You are just getting rid of organic materials. Why? Because you will feel the emptiness with the wax. Why in the wax? Because we are sectioning it up to 5 micrometers. Just think about it, micrometer to centimeter, there's 1,000 of fold in that length. So it is impossible to do it by hand. So we have special instruments just for it. So before this sectioning period, we are clearing the organ and changing its nature to fill it with wax. And at the final result, we are having these sections. Maybe you can see them at pathology, you can see them at the microscope, but it is the final result of histological processing. In clearing, after alcohol replaces water, then we have xylene. Xylene dissolves alcohol, and it is changing the organic material, and the paraffin and the wax is the last part. We are filling the emptiness with the paraffin. Paraffin displaces xylene, and we are mounting it in the paraffin, and now we have just one medium can be cut via special apparatus called microtomes or ultramicrotomes. Embedding paraffin, I mentioned. Sectioning microtome, the instrument I mentioned is this. We are putting our paraffin block here, and here we have really sharp knife, and just cutting it 5 micrometers each and collecting it with our special laboratory glasses, lamps, and we are doing our staining and having the final results. So I want to start with that part, because when we are showing the students and showing the public that this is the result of histology, they don't know the background. It is the background of the histology and pathology. Staining is the fancy part, and we have some kind of spatial stains. It is not about fashion, it is about the duty, it is about our goal. So if you want to work on energy metabolism, you are working on you must stain periodic acid and Schiff, because it is more effective in glycogen and mitochondrial metabolism. If you want to see the main structure, you must use hematoxylin eosin. If you want to see the connective tissue and their effect, if there is a metabolical disease, you must choose Alcin blue. And this tree is just parts of it. I can say that there is a huge book just for it. Just in my career, I am a histologist for 10 years. Maybe I performed more than 100 type of stains. So there is still more, and I know that I know nothing about it. When we need something, we are searching literature for it, and we are choosing the best one, which fits our goal, and we are choosing that staining. We are performing it, trying it with control groups, and we are doing our stainings and having the results. Doing our, it can be anything. We can make our histological scoring. We can do some AI application. It depends on our work. So, briefly, we have our sample, fixative, alcohol, dehydration, clearing, infiltration, and decalcification in some parts if you are working on the, for example, bones, because bone has different structure than the muscles. And it is also another problem. Also, for this problem, we are using AI. I won't mention here today, but it's also one of the problems. In human body, in microanatomy, they may be some kind of different kind of solidity. For example, if you are working on the lymph generation, it means you have nerves, you have skin, you have bone, and you have muscle. Both of them had their different biophysical compartments. So for this, we may add sometimes extra steps to get the best results. Then we are having our paraffin blocks. We are changing the stuff inside, and we are just sectioning it and having our slides. Here, I want to be sure that you understand how an organ transforms into a glass. Now it is just ready. It's still not ready. It is paraffin sections. It is still not ready to investigate. And then we will choose our staining and make our staining. Then it is ready for microscope. So think about it. It is how much labor-based work there is still working on, and there is still no AI working on it. But probably Kaan will work on it, and I think he has a very good idea about clearing. Methodology of my presentation is I want to just introduce the scientific perspective. I want students to dream without borders, but just be ethic. I will mention about Web of Science and importance of keywords and citations, because I choose 5 different cases and my own case said thoroughly. For my case, I cannot talk a lot because it is intellectual property still under protection. We are working on Helmholtz Institute. I will say, of course, I will say something, but I cannot say everything about it. But I think it's just kind of rebranding, and it's a, game-changing procedure for histology. Let's talk about case 1. In histology, we can use AI to create contents for science. It is also creating contents. I know there is a lot of Generation Z. This content is not for social media, it is just for science. For example, in that example, as I mentioned before, you remember, Mr. Gürlekoğlu, we talked about we are still investigating in brain. For example, in here, the scientists work on thalamic nuclei. Thalamic nuclei is a vital nuclei in the brain, and we are still producing atlases because for conventional methods, there are a lot of blank points we couldn't understand. So we are using AI just to understand the main parts, just to understand the big picture of one nuclei. Think about it, there is more than 300 nuclei types in just one section of the brain, and for just one of it, we are using AI to understand the big picture. So you can dream that how much we should walk more and more to say we understood, we understand the brain. There is still a lot to learn. Here you can see another type of sectioning. It's called frozen section, but it is more or less the same. As you can see, my college just make frozen section, cut them, and have some kind of histological picture and make some edition with MRI. So computational pictures and collecting and merging with histology and MRI. They are having one more type of picture of thalamic nuclei, and they make a codification about it. For every color, it is just forming another type of nuclei, another type of structure, and collecting this picture. They are having that. In the picture B, you can see parts that we know. We know that, for example, the violet part, we know what is happening here. But for the gray part, we don't know what's happening here. So via AI, we are making some kind of, how to say, good guessings. Here, we think that, yeah, if this part is working on blue, so pale blue, and there is somewhere we don't know what's working on, and we have one more pale blue line, AI want to predict that this part may be a all pale blue part, because it is the best we have. We need someone say that this gray part is not pale blue, it does not have the same organization, it does not have the same duty. So for that part, we have histology, we are doing different stainings to see the difference. If the structure stained the same, we are just predicting that probably it is working on the same duty for the brain. For example, it can be eye blinking, it can be just finger crossing, it can be anything. But for our knowledge, we are just competing with MRI pictures, so we are just seeing action and reaction, and we have morphology, and we are just combining them via AI and having the atlas of thalamic nuclei, just one nuclei of one part of the brain. Here we also have our control group, which is Alzheimer. With Alzheimer and control group is the, how to say, for thalamic nuclei, we are saying that control groups are the people who don't have any problem with the Alzheimer. They don't have, we cannot observe any, how to say, a behavioral effect of Alzheimer. And we have Alzheimer brains. We know that their thalamic nuclei is just really problematic. So we are using both of them to understand our normal one. Normal, I mean not Alzheimer, not diseases one. We have our ratios for every microseconds. We are changing, we are sending light and turning it back and want to see the differences. And we are just combining them with histology, but it's not doing by the humans itself, because it is, how to say, there are a lot of little pixels we couldn't understand, we couldn't see them. So we are using AI to create this atlas, create this map. It is just a map, it is just a strategy. So, for the second case, I want to talk about mitosis. We talked about organisms. For the hierarchy, after organism there is organ. And now I'm going from smaller part from the greater part. And from organ there is tissue, smaller part. Tissue makes the organ. Then we have cells. In the cells we have organelles. One of them is nucleus. So for the anatomy, organism matters. For the histology, for the biophysics and physiology, organ matters. And for histology, tissue, cell, and organelles matters. So last three hierarchy is part of our discipline. And in that work, people are working to understand the biology of cancer via the mitosis effect, because in cancer, mitosis is more active than the normal cells. So here, mitosis is not easy to understand by human eye, because this picture, I can say, in my computer, for example, as a histologist, if I take the pictures from a classical 17-inch monitor, I see only that part of the picture. To count every one of the mitosis, every one of the cells, I need not a lot of computer, but a lot of time to understand it, but I am not choosing it. Like in Kahn's method, we are choosing to educate, we are choosing to teach the AI to say that these parts are the cells and they are going mitosis, just detect me these parts. But there is still some problems, of course, because it is not easy. We are using layered architectures. Kahn, I think, also mentioned about it. When we are making it more and more deep, sometimes we may miss some points. If we are making it more general, probably we will miss everything. So keeping it just enough is the key point. It doesn't mean that if you have 13 layer architecture for network, it is not enough, you may do it 99 layer. No, it is not right. For every architectural layer, you may miss some point. We just need what we need. For example, here, my colleagues are still working on it. When the AI just capture the pictures, the human eye is controlling them and try to understand the true ones and the false ones. So what are we doing here? We are choosing the true ones and still just teaching the AI that these ones are true. It must be more like that, and we are still using the false ones and educating computer that these are the false ones. And you see some numbers under it. When it is going to the 1, it means the absolute true. When it's going to the 0, it means it's absolutely wrong. You can see some true in that part. It doesn't mean that this part is 0.1. So we want computer that it is not a mitosis. If it's writing true, it has done its work. So for the case 3, histology is also multidisciplinary, and in our work we are using a lot of convolutional networks. It's a Joker medical size, and we can compete it with a lot of basic medical sciences. Like in here, you remember how we get this whole slide image. In pathology, like in histology, we have the same methodology, but just different perspectives. We are taking our resection and biopsy and having this picture more than 800K pixels and try to just process it. In convolution method, we are just changing for computer to understand it better. And we have our pooling. In our pooling process, we are choosing our parts. And for the outputs and inputs, we are just controlling it. With every conventional layer, we are just, the computer is just becoming better, understand. It is more like seeing great pictures with different perspectives. In conventional networks, we are just educating, we are just teaching the computer that we are just teaching the algorithm that having more visionary, the deeper, the larger perspective. So how are we doing it? Not only with histology, so we are just getting help from genetics. Let's make it to understand better. There are some samples, and with orientations, with just giving it some values to make it, to scoring it, to understand it better for the comparisons. And we are just calculating median risks, the faults, it is the right parts and wrong parts all together. Because when in pathology, when you are educating the algorithm, and just giving it the right parts is not enough. You must also teach it the wrong parts to get, to get its lesson from its faults. So in health sciences, to getting learned from faults is, I think, as important as it learning from 0. So we are just taking our points, taking our median points, and try to educate it part by part, one by one, and try to make it just merge and diverse it again. Here, we are also using our genetical outcomes. For example, we have had our genetical tests in the cancer, and up to now we just talk about the pictures, just talk about the morphology, just talk about if there is cell, if there is one line, if there is some dots or some lines, this means this. Here, we are getting help from genetics, and even histologically it looks completely great, completely okay. With the genetical data, it can be manipulated. Not only with histology, with the genomes. So in that graphic, as you can see, the grading of the histology is like between here. Here is the genomics, here is the histology. But when we just combine histology and genomics, we are making these little differences. These differences may look really, really small. Sorry, I had a problem. I will be faster, I'm sorry. These little differences may save millions of lives, depends on the project. If, for example, it's about mammary cancer, these little differences may save 100,000 people each year. So every difference is just, it can be 1 in the million. It doesn't, for the scientist or for the paper, maybe it doesn't mean anything, but for that individual, the technology saved, it means a lot. So, sorry, I will be faster. We can also use it for clinical aspect, like in digital pathology. Here, sorry for my time. For example, picture A is the picture, original picture, but picture B is made up. It is just drawn by the computer. And in the paper they say that they are showing this picture to the pathologist, and 95% of them just saying that it is not fake, it is just ordinary pathological picture. And here even it is not even anything, it is just randomly dots made by biorendering systems. And even for this, AI may say that it may looks like this. So it is the level we just reach in the AI technology in our discipline. For example, here we can also draw some lines to get cancerous tissues, just separate from another ones. Here, for example, it is our tissue. It is the color we want to understand it better, and it is the final results. So we can educate algorithm about the colors, about the shapes, or about merging. For the second picture, you will see immunohistochemistry. We are using it for some spatial antibodies to get to understand the type of the cancer, to get to understand risks. It is, how to say, more expensive than the classical methods, but we can just merge them and understand the bigger picture better. So, for the last ones, we can also see the feature via AI. Here you can see the sensitivity and specificity. While we are educating the algorithm, it is making some zig and zags, but the median line is what we want. We are using for cancer recurrencing. We are using our models for recurrencing or non-recurrencing. We are just educating AI onto it. And if there is recurrence tissues and non-recurrence tissues, we are making educating it via some conversions and efficiency net systems. And after then, we don't want result. It is more about just saying that there is a possibility of recurrency or non-recurrency. So via AI, we can also make predictions about the future. For example, like here, we are making our points. If AI can detect some place like that, and all the recurrent tumors have that place, yeah, the AI say that I found the same thing. It is the main part. It is the, how to say, common part of every cancer patients. It means that this cancer may recurrence itself again in 5 years, in 10 years. We are discussing it. For the case 6, it is the least, the part least I will talk about. It is my own project. We are just rebranding the histology itself. You remember I talked about the clearing systems, but clearing systems is mostly about the part of the organs. Here we are doing clearing with whole body. It means when I will work on the rat, for example, it can be about MI, myocard infarctus, heart attack, whatever you call it. For example, when we are working on it, we are mostly sometimes only in heart. If we have more budget, we can also work on liver and other organs. But with that method, like you see here, we can work on whole organism, so we can understand the effect of the diseases, effect of the drugs, and effect on the agents in whole body. To do this, we are also using AI imaging methods, because every picture of it is like picobytes, not gigabytes, every time it's picobytes. So we are using AI to process it, process the pictures, process the results. And we are using ultra microscopy to understand it. As I said, that every second it is working, it is just spending the same electricity of an 20 floor of apartment. It is how to say, golden standard technology in our discipline. I want to thank my team, which we are talking about. I want to mention that I am not the center of that team. I am just talking with my friend. Everybody is center of our every project. It is just my story. That's why I am in the middle. I am getting help from all of my friends, all of my colleagues here. I want to thank, for example, Canberk. He's a medical histologist. You have already met with Kaan and Hussein. Zeynep is our younger student. She's a junior researcher, and you don't see our professor, head of lab, Professor Dr. Itonikil, and our senior researcher, Johnson Shirin, which we are working on together, like in the project Kaan mentioned before. And thank you for your attention. Sorry for some kind of time limits. I am trying to explain it as clear and as scientific as possible. And in our little short time, I can answer your questions.
So I won't talk anymore. I want my students to talk or ask something.
Seljuk teacher, you are unmuted.
I'm sorry. I don't have any questions, but I want... Indeed, we have 4 minutes, and I'm sure our students are tired anymore. Indeed, I wanted them to ask you some questions, but I think we don't have time. There is a song, you know, it's time to say goodbye anymore, I think.
My email to the chat. If any of the students have a question, they can ask whenever they want.
Yes, we can ask them to write in the forum on ESET, and then you can address these questions to our specialists.
Yes, they can ask us whenever they want, and we will reach you again. And thank you for sharing your time with us at that time. I know you are very busy people, and I want to thank you again.
Thank you very much. Thank you very much.
Thank you for sparing your time to us.
Okay, I think, is there any question, really? My students, there are some students, I see my students. Or do you want to say something, dear students?
Teacher, they explained everything perfectly.
And you understood everything perfectly, right, Çağlar?
Yeah.
Okay, you don't need to go to any high school anymore. You are, okay, you can go to university whenever you want. Great.
All three of us are working in the Ege University Faculty of Medicine, Department of Histology. So we are waiting for each other in the next couple of years.
So let's plan it, really, let's go, my dear students, let's go and visit them on work and their precious machines and their microscopes. I really wonder, looking at the
I mean, not as a student, as a homeowner, I mean, in the future.
I hope so. I trust them, they are very hardworking students, and I'm sure we will do great things together with them.
Yes, one day we'll invite them like a specialist.
Yeah, I hope so. It will be a great honor for us, for teachers, as teachers, and seeing our students somewhere very important places and helping humanity. My biggest dream is this, giving them inspiration. So meeting with people like you is very important for them, because if you know there's a path, you can choose the way, your own way. But without knowing there's a discipline like histology or other departments, they can't choose it. So they have to learn at first. They have a kind of, at least an idea about the discipline, and they can go on this way. I think these meetings are very important for this thing.
I would like to ask you.
Yes, Diana.
I would like to ask you if you have Romanian students in your university.
We have Romanian. We had a Romanian college at pathology. I can't remember the name, but no students, not from Romania. Romanian students, as it is understandable, choosing mostly European Union countries' universities, I think for bureaucratic reasons. But we have a lot of Azerbaijani students working on.
Yes, Azerbaijani students striving to come to Turkey to continue their education, to take trainings.
And one of the most successful, and I can even name it, Ziya Kerimov. He will have a great future, I guess. He's in his 5th grade. He's even in that part. He has a lot of publications, books, and stuff. He's really a bright boy, I can say.
But it's pity that not all of them return back to the country and work for their nation. That's the bad point of it.
Yeah, the different subject, but I understand it.
If they stay in Turkey,